All right, so the next thing we're going to do is integrate our little to-do list with local storage. Basically, we have this list of to-dos, and every time you add a new one, I just want to update the to-dos in local storage. If you're not familiar with local storage, it is browser-based storage. It's very simple. We can only store text or strings. So we have an array. An array is not a string. So we need to convert it into text, but of course we want to do it in such a way that we can get it back out. So we'll use JSON. We'll stringify on the way in and then JSON.parse on the way out. So when we make a new to-do, we make our object, we actually create the new to-do on the page, on the document, and then we push it in the object representation into our to-dos array. And then we could save to local storage right here. So we would do something like local storage, and then we use the set item method in order to add a value or update an existing one in there. So we have to give it a key that we'll store it under. I would just call it to-dos. And then what we want to store has to be a string. So I can't just store the to-dos object. And thankfully TypeScript knows all about the types, and it will say you can't do that. This has to be a string. And right now it's a type, or it's an array of to-do objects. So we can stringify it, and we can do it inline, we can do it up here. Let's do JSON.stringify our to-dos. Okay, so let's check out what happens when I try and make a new one here. Walk the dog. It's added to the page, no problem, but let's look at local storage. Local storage now has a to-dos property that is set to the JSON, the stringified version of my to-dos array. And if I add in another one, walk the dog, feed the cats, look at local storage again, now we have this it's hard to see, but a longer string that also includes feed the cats. And I refresh the page, that's going to be there. That's the point of local storage. So the next thing I want to do is when the page loads, at the beginning, I want to load those to-dos from local storage. I want to read them out. So how would we do that? Just up here for now, somewhere, we do local storage.get item under the key of to-dos, if that's what we stored it under. And if it finds anything, it's going to be a string, right? So this would be like to-dos text or JSON. And then we need to parse that. So JSON.parse to-dos JSON. And then that would hopefully give us our array of to-dos. If I just did how about a console.log? And this will just happen when the page loads. And there we go. We have our two to-dos successfully read back out as objects in an array. And I want to take advantage of my types. So I'm going to make this into a function, I'm thinking. I'll have a function called like read to-dos, maybe like that. And we're going to look for to-dos in local storage, right? Hopefully we find it. But the thing is, this is either type string or null. So I'm going to get a complaint down here. So we're going to learn more about type narrowing later. But basically what I want to do is make sure TypeScript knows that we're handling the null case. And it's not a good idea to just assert that it won't be null, because what about the first time someone loads this page? It definitely will be null. So instead, we'll do something like if to-dos JSON is equal to null. If that's the case, we'll just return an empty array. Otherwise, we're going to return JSON.parse of our JSON that we got back. And now TypeScript doesn't care, because it knows if it makes it this far, we found something. It is not null. And we're going to cover this in type narrowing. It's a fun section as far as TypeScript goes. But yeah, it's a really common thing to have some value that could be null, could not be. And then we can rule out the null case, and TypeScript can figure it out. If we make it to this point, to-dos JSON has to be a string because we returned otherwise. Okay, so now we have our read to-dos, and read to-dos is supposed to return an array of type to-do. Why not use that interface? Keep things as typed as possible. Instead of what it returned here, if we just look at it, the inferred type is just any. That's not very good. We want it to return an array of to-dos, and that way, up here, when I initialize my to-dos, instead of having it be an empty array at the start, I'm going to call read to-dos. And that returns something of array type to-do. It could be empty or it could have to-dos in there. So now I am hopefully able to read those to-dos, and we won't see anything show up on the page yet when you load, but I should have an array of to-dos, and I do, successfully with showing whatever we have from local storage. So that's great. Now the next step is to actually add those to-dos to the page when we load, right? So to the DOM rather, instead of just this array in memory, we want to view those to-dos on the page. Well, we already have this create to-do function. So basically, once we get our to-dos, the very first thing we want to do is call create to-do for each element in this array, if there are any. So we'll just use for each. That's the easiest thing, right? To-dos.for each, and then create to-do. And that will work just like this. We don't have to do anything fancy because each one of these will be of type to-do, and create to-do expects something of type to-do. So we're almost there. I have an error because of the order that my code is running in. I need to make sure that we have the list and all these DOM elements defined first, at least by the time I call this line, which is actually appending to-dos. We have to make sure we have the list selected. All right, try that again. Hey, it's working. Walk the dog, feed the cats. Awesome. Okay, so we are almost done with this. In the next video, we're going to connect the checkbox and have that update in local storage as well, so that you can mark them completed. But for now, let's just, do the dishes as our next to do. Refresh the page, and that is successfully saving in local storage and being read out from local storage. Awesome.